Ok, entonces, ¿se me escucha? Si alguien puede escribir en el chat. Ya. Bienvenidos a esta sesión. Esta sesión es Deploy End Applications to End Clusters using Argo CD ApplicationSet, a cargo del charlista Dewan Ahmed. También quiero abrir un espacio para presentar a nuestros patrocinadores. Agradecemos profundamente el apoyo de JetBrains, Avatar Tech, ERC, Streamdevelopers, Synergies, la editora MLBI y la Pontificia Universidad Católica Madre y Maestra. Les recomiendo usar la funcionalidad de preguntas y respuestas que deseen hacerle a nuestro charlista. De esa manera la podemos tener en orden y no se pierden en el chat. Las preguntas las pueden hacer durante la sesión y al final se van a responder, evidentemente. También recordar sobre las rifas. Las reglas es que tu perfil va a estar público, debes utilizar hashtag Barcamp RD 2021 y etiquetaremos la publicación. Gracias una vez más por estar con nosotros y demos inicio a nuestra charla. So, thank you, Dewan Ahmed. You can start now.
Awesome. Thanks so much for the introduction. I'll start by sharing my screen. And apology in advance because I have a bad cold, so I might cough during my talk. All right, so you should be seeing my slides in full screen again. It's a beautiful morning, and thank you for joining this session, Deploy End Applications to End Clusters using Argo CD ApplicationSet. My name is Dewan Ahmed. I'm a senior developer advocate at Red Hat, and I'm in the beautiful New Brunswick, which is the eastern part of Canada besides the Atlantic. I love everything cloud native with a focus on DevOps and GitOps tools. Besides work, I love to play pool, ping pong, and I'm also a freelance career coach. That means I help students and new grads to start their career in tech. Those are my LinkedIn and Twitter handle at the bottom of the screen. I'd love to connect with you. In terms of today's agenda, we'll cover what is GitOps and why should you care about GitOps. We'll talk about Argo CD, a community project that does GitOps on Kubernetes. And we'll talk about the what and why of ApplicationSet, a sub-project of Argo CD that helps you deploy to multiple clusters at the same time. Both of these will be followed by a demo, and then we have some time for Q&A as well. If you have a mobile device, you can scan that QR code, and that'll take you to a repository. So let me get out of the full screen and show you the repository. So this is the repository for today's demo. I'll be using OpenShift for my demo. For those of you who would like to know more about OpenShift, I think I have added the link in the chat and also the link for Argo CD. Now, this repository, it has the entire demo using the community version of the project, which is Argo CD. For my demo, I'll be using OpenShift GitOps, which comes as an operator. Now, in this repository, I have added all the resources that you might need to get a good sense about GitOps and some tools on that. I've also added the slides, which you can find here under the slide section. So this is the slides for today, which you can find here. And finally, I have added an FAQ section. So if you go over that, if you might have commonly asked questions, you might be able to find the answer there. All right, so let's come back to our presentation. I do have some assumptions because this is an intermediate level talk. I am assuming that you have some knowledge about Kubernetes and the continuous delivery landscape. Even if you don't, that's totally okay. You can read up on Kubernetes, do some hands-on exercises on Kubernetes, and then hopefully this will make more sense. All right, so let's start with the idea of GitOps. So what is GitOps and why do we care? Now, this is from the GitOps working group who came up with 4 principles. The first one is the principle of declarative desired state. So what this basically means that in the imperative way, so let's say you run a script, and in the script you say, run this command, do X, Y, Z. So you're just telling the computer to do those things. It's a very straightforward way of saying, but there's no feedback, right? The declarative way is you're describing how you want to see the system. I want to see 3 versions or 3 copies of my application deployed in the server. For example, replica. And that's more like a declarative way. And that's readable by both humans and machines. The second principle is principle of immutable desired state versions. That means whatever you're declaring has to be version controlled. So let's say you want 3 copies of your application and someone went ahead and changed that to 10, right? That has to be version controlled so that you can audit at the later time that who made it to 10 copies, right? The third principle is the continuous state reconciliation. So you have your Git repository. And one thing to clarify here is you have your application source code and you have your configuration for your application. So in today's talk, I'm focusing on the configuration part. So your configuration, which is in your Git repository versus how your application is on your Kubernetes cluster, those might vary. If it varies, then your GitOps tool or software or whichever engine is sitting in the middle, that will start a reconciliation process that says in your Git repository, you had this desired state that wanted 3 copies of your application, but on the cluster, I see it's only 2 copies. So I'll do the reconciliation to spin up 1 more copy of your application. Now, it doesn't matter whether that change is in the Git repository or on the cluster. As long as there is a difference, the reconciliation will happen. The fourth principle is the principle of operation through declaration. And what that means is when you do any operation, creating, managing any resources, you do that operation through Git, by Git push, not direct kubectl command on the cluster. Now, this is for regular operation, not for emergency break glass procedure. If it's some emergency and you have to put out fire, you turn off or pause your GitOps engine and then you can do some emergency work. But this principle strictly talks about regular operation, all right? So now that's clear. Let's understand what we need to do GitOps on Kubernetes. First of all, you need your Git repositories. Then you need your Kubernetes clusters where you're deploying your application. The third one is you need some sort of manifest generation tool. For example, if you have a dev environment, a pre-prod, prod, you need to manage manifest for those environments. A tool like Customize can help in this regard. Then you need a CI tool because your CI server should not do direct deployment on your cluster. And in the GitHub repository, which you showed earlier, there's a nice blog which says why CI ops is an anti-pattern. And the last point is you need a way to group your Kubernetes resources, your deployment, manifest, service, those YAMLs. So what is Argo CD? Argo CD is a GitOps continuous delivery tool for Kubernetes. It's an open source community project, and it does these things, and that answers why Argo CD. First of all, following the GitOps principles, it uses Git as the single source of truth. It's developer-centric. That means your developers don't have to worry too much with the complexities of kubectl commands. They can follow their Git-based mechanism, and then Argo CD will ensure that the declarative state is reflected on the cluster. In terms of security, Argo CD offers single sign-on based on OAuth 2 and OIDC. Argo CD also offers multi-tenancy and RBAC policies for authorization. And finally, all the calls that are happening to the Argo CD server are auditable. Argo CD trivializes rollback. That means, let's say you did a deployment and you want to roll back. It's a matter of git commit because everything is git commit. You can go back to a previous version of the commit. Also, everything you're doing is observable. You can see the difference of your declared state and desired state either from the UI or from the command line. And finally, keeping all this in mind, your engineering team will have a much higher velocity to deploy their application on Kubernetes. Let's see how Argo CD works. So this is a typical developer flow where developer does a PR merge, and then based on a webhook event, so this blue rectangle is Argo CD, which is installed as a Kubernetes controller. So Argo CD listens for that webhook event. So when Argo CD sees that there's a change in your Git repository, Argo CD tries to match, because which is your Kubernetes configuration on the cluster. So Argo CD sees whatever you did make change using the git push or the PR merge. Now, is that desired state the same as the cluster's actual state? If not, Argo CD will call your Argo CD application out of sync. When the application is out of sync, you have to run either manually or automatically sync hooks, sync operation. This sync operation can be straightforward, clicking a button or an execution of a command, or it could be a complex sync hooks, which means, let's say, if you have complex deployment, you might want to run some scripts before, during, or after the sync operation. And you can add some app actions within that. Argo CD API server exposes its gRPC REST server either to the CI/CD systems or the Argo CD UI and CLI. And finally, you can see that you can deploy your applications to multiple Kubernetes clusters. All right, the thing we all love. So let's look at a demo for Argo CD, how you can deploy an application from a single Git repository to a single Kubernetes cluster. So in this demo, I have my typical deployment and service YAML, and I'll try to deploy this application from this single Git repository to a single Kubernetes cluster. So I'm creating an application using Argo CD UI, and first step is I have to copy the link of the Git repository. I can give my application a name, and the project is Argo CD project. I don't have any other project, so I'm selecting the default project. The sync policy I'm selecting as automatic. Now you have two sync policies. One is manual, one is automatic. If you do manual sync, you have to click either the button or run the command for the sync operation to happen. I'm going with automatic sync policy. There are two options here, prune resources and self-heal. If you select prune resources, that means if you delete a resource on your Git repository, Argo CD will delete that resource on the Kubernetes cluster as well. If you select self-heal, that means that if you try to delete a resource on the Kubernetes cluster directly, Argo CD will reconcile and recreate the resource for you as if the cluster self-healed. So I'll select both of these options. So I already copied my repository URL, and this is the path customized as guestbook, where I have my manifest files, customized -guestbook. I have installed Argo CD on the same cluster. So Kubernetes.default service is the cluster URL, but you can deploy to a remote cluster as well. I can override my customization file, so I'm adding an XYZ prefix, and you'll see the resources being created will have an XYZ prefix. So let's look at the application, and you can see both the service and the deployment has an XYZ prefix. And I have my Argo CD application created. It's synced, and that's a very straightforward example of using Argo CD to deploy an application to a single cluster from a single repository. So what are the challenges here? The first challenge is, let's say you don't want to deploy to one cluster. Let's say you're trying to deploy your application to 10 clusters. How about 50 clusters? Or you might want to deploy from a monorepo. That means your repository has multiple folders, and each folder is one of your application configuration. So with the regular use of Argo CD, you need to create one application for each of this combination. Deploying to 50 clusters, that means you need 50 Argo CD application. Now that might be a bit difficult to manage, right? Introducing ApplicationSet Controller for Argo CD. This is a sub-project of Argo CD, and again, it's installed as a controller on the same namespace where Argo CD is installed. So you can see the type is ApplicationSet, and here it offers various generators. So currently, I believe there are 6 types of generators, and you can find more details on the ApplicationSet documents page. But this example of list generator, what it does is here you can add all your clusters as a list. Name your cluster and a cluster URL. And using one single custom resource definition file, you can deploy to 3 clusters here. But these 3 could be 100. So ApplicationSet Controller takes an ApplicationSet custom resource as an input and spits out one or more Argo CD application. So you can think of ApplicationSet as an application factory for Argo CD. Now, how does ApplicationSet Controller work? So ApplicationSet Controller only creates Argo CD applications, nothing else. Argo CD actually creates, manages, and deletes your Kubernetes resources for you. ApplicationSet Controller does not connect to remote Kubernetes clusters. Your remote Kubernetes clusters already have to be within Argo CD for that to happen. Finally, ApplicationSet Controller only makes changes within the namespace where Argo CD is installed, not in other namespaces. So from these examples, you can imagine that ApplicationSet Controller uses Argo CD to do all the heavy lifting. It uses templating and automation to create multiple copies of Argo CD application. So these are the 6 generators currently we have. In today's demo, we'll talk about list generator and git generated directory, which is similar to a case where you can have a mono repo. All right, time for another demo. So in this demo, we'll see how we can deploy to multiple clusters using ApplicationSet. So in this demo, I'm using OpenShift and OpenShift GitOps operator, again, which is open source, and it is installed as an operator within OpenShift. And the 2 examples I have, first one is list generator. So if I go into list generator and git generator directory, this is the repository, which I have linked at the beginning of my talk. So these are the 2 examples for our demo. And you can see the kind is ApplicationSet. This is the repository URL where I have my application configuration file. So I'm deploying to 2 clusters. One is engineering dev and one is engineering prod. So engineering prod is currently commented out because I'll copy the actual remote cluster URL and then uncomment it when I actually create the resource. So the template section, you can see this is an Argo CD application. The only difference is some of the parameters are dynamically generated. For example, the cluster name will be engineering dev -guestbook and engineering prod -guestbook. And the same thing for the URL, which will also be dynamically generated based on these values for URL. The sync operation create namespace equals true means if the namespace does not already exist, Argo CD will create the namespace for you if it has the permission to do so. So this is the operator which is installed as a cluster operator in all namespaces, and it creates the OpenShift GitOps namespace. So for OpenShift, imagine OpenShift GitOps to be same as Argo CD. So in Kubernetes, how you install it under Argo CD namespace, here you install it in OpenShift GitOps namespace, and the controller name is OpenShift GitOps controller. So I'm using the out-of-the-box admin password for Argo CD server. For OpenShift, you can find it under workloads, secrets, and OpenShift GitOps cluster. Of course, if for production use, you might want to use single sign-on rather than using the default password. So first of all, let's see. I don't have any remote cluster added. This is the cluster where Argo CD is installed. That's why it says in cluster. But we'll make that change. We'll connect our remote cluster pretty soon. Cluster, we have to use Argo CD CLI. As of now, you cannot add remote cluster using the UI. Argo CD is pretty picky on how you format this URL. So I'm using the same out-of-the-box admin password. So once I'm logged in, I have to use my remote Kubernetes clusters context to add the cluster. I'm using a handy little tool called kubectx to quickly switch between Kubernetes cluster context. So this is my remote cluster. And the command to add a remote cluster is Argo CD cluster add followed by the name of the context. Once I execute the command, Argo CD will create a service account, a cluster role, and a cluster role binding on the remote Kubernetes cluster so that Argo CD can make changes in the remote cluster. So let's start with the first example, which is list generator example. So deploying an application from a single Git repository to 2 Kubernetes clusters. So I'm copying the YAML. So you could create ApplicationSet either from the command line, or I can create it from the OpenShift console as well if you're using OpenShift GitOps. So create ApplicationSet, and you can use either the form view or the YAML view. So I'll choose the YAML view and paste the YAML, which I copied. And this is the time where I'll change the cluster engineering prod details. The other thing is you can see the namespace name is guestbook-ns, which is different than OpenShift-GitOps namespace. Now, Argo CD or OpenShift GitOps does not have access on that namespace. This is by design for security purpose. So what I have to do is I have to create the namespace with this specific flag or label that is called managed by OpenShift GitOps. If you create namespace with this flag, Argo CD or OpenShift GitOps controller will be able to make changes in that namespace. This is specifically for OpenShift GitOps. So now, if I go into cluster, you can see that I have now remote cluster added. And I'm replacing the URL of my engineering prod with that remote cluster URL. With that, let's create the application set. And on the Argo CD UI, now I can see, as expected, I have 2 Argo CD applications created using one custom resource definition, engineering dev guestbook, which is in the same cluster where Argo CD installed, and engineering prod guestbook in the remote cluster. So let's try to delete one of these applications directly from Argo CD UI. So in a previous way where we created application using Argo CD, if I try to delete an application, the deletion would persist. But here, if you observe, even if I was able to delete the application, because these applications were created using ApplicationSet Controller, ApplicationSet Controller will recreate your Argo CD applications for you. Now, this is a pretty a good practice if you have multiple Argo CD applications and you want to make sure that no one accidentally deletes that. In order to actually delete the application, you have to delete the application set, and the child Argo CD applications will be deleted for you. So that was list example. Now look at git generated directory, which is for the monorepo example. You have multiple applications. So these are all same example. I'm just using different name for demo purpose. And again, because I don't have access to the guestbook Helm namespace, I have to create those namespace beforehand using that special label that managed by OpenShift GitOps. This is true for all three namespaces. We'll have to take guestbook Helm, guestbook JSONit, and guestbook Customize. And these are my three applications. And this is the application set. So again, if you see that metadata, the name is dynamically generated. So line number 14, path.base name, whatever matches the path in line number 11, those will be the name of your Argo CD applications. All right, so let's create the application set and see what happens on the Argo CD UI. As expected, now I have three Argo CD applications created from a single custom resource: guestbook Helm, guestbook JSONit, guestbook Customize. The only difference is in the previous setup, I had auto sync enabled. That's why the apps were automatically synced. For this one, I did not have auto sync enabled. So by default, the applications were out of sync. I have to manually either click the button or run the command to sync these applications. So once I do sync, all three applications will be in sync, and JSON takes a bit of a time. And all three applications now are in sync and healthy. The health metrics is a way for Argo CD to see if your app is healthy. For different Kubernetes resources, it uses custom health metric, different health metrics, and if you can add your own custom health metrics as well for your custom Kubernetes resource. Again, this example was using OpenShift and OpenShift GitOps operator. If you'd like to follow it using vanilla Kubernetes and the community version of the project Argo CD, you can follow this particular repository to do the demo yourself. All right, so let's go back to our slides. So what did we learn today? Today we learned about GitOps and the concept of GitOps and how you can do GitOps on Kubernetes using a community project Argo CD and the OpenShift version for that using OpenShift GitOps operator. And you have access to this repository, which has the entire demo, the slides, and some frequently asked questions. Thank you for your time. And at this point, if there are any questions, I'll be happy to answer those.
Okay, thank you, Mr. Ahmed. I'll lead you to the questions right now. The first question comes from Lacey. She says, it's a very interesting project. I didn't know it. I've seen that it has a couple of years of age. Has someone worked with Argo CD? Or the question will be like more like if you have worked with Argo CD already in some projects.
Great question, and thank you for the question. Yes, so I take the question as how mature the project is. The project is very matured. There are a lot of products that is based on this project. OpenShift GitOps, which is an operator for OpenShift, has Argo CD as the underlying engine, and a lot of customers are using Argo CD in production. Argo CD is also one of the popular choice for machine learning based models because it can do like graph based deployment. So maturity-wise, the project is pretty mature, and it is being used in production.
Okay. So the other question well, it's like bad phrase here, but is Argo CD working with GitHub Actions?
Great question. I think the question is more like, can I integrate GitHub Actions with Argo CD? You certainly can. So if I think my continuous integration part using GitHub Actions, that means you have some sort of GitHub Actions that builds your code repository and then makes any changes to your configuration repo. Once that happens, Argo CD will automatically know that something changed in your configuration repo and it will do the reconciliation. So definitely that can happen. I don't see GitHub Actions making changes directly to Argo CD or vice versa, but definitely you can use both of them together, one for the CI piece, other for the CD piece.
Okay. Thank you for your answer, Mr. Ahmed. The last question is, does Argo CD have some kind of alerting system to notify in cases in which the cluster health gets degraded for some reason?
Yeah, absolutely. So I'll mention about some of the notifications for OpenShift. So with OpenShift, on the OpenShift console, there are a lot of customer notifications. So for example, if your application is out of sync, you can see a notification on the main console. You can also see similar notification on the logs on the OpenShift log, and you can add your custom notification. For example, you can have a Slack webhook that tells you that if something happened, but for OpenShift, you have this custom notification directly on the console.
Okay, Ahmed, thank you for your answer to that question. Does anyone has any questions? I think that's not the case here. So thank you, Mr. Ahmed. We really appreciated your support in Barcamp in this edition of Barcamp RD 2021. It was a great session. Thank you.
Thank you. And I'd leave my LinkedIn URL in the chat. And for those of you who'd like to connect, please connect with me on LinkedIn.
Yes, if you want to connect with Mr. Ahmed, I'll be posting here in the chat the LinkedIn profile. Yeah. There it is. Thank you.